Welcome to The Explainer. Today, we are diving into a brand new AI model that isn't just trying to keep up. No, it's making a play for the top spot. It's called MiniMax M2, and it's making a claim that is, well, pretty bold. It could shake up the whole field.
And yeah, this is the claim that's got everyone talking. I mean, right out of the gate, the creators are saying its composite score ranks #1 among all open source models globally. In today's AI world, that is a massive, massive statement. So you know what we have to do? We've got to unpack it.
Okay, so how are we going to tackle a claim this big? First, we'll look at that #1 contender claim. Then, we'll meet MiniMax M2 and see what's under the hood. After that, we'll put it under pressure with some tough tests, explore its efficiency advantage, and finally, I'll show you how you can try it out for yourself. All right, let's jump right into Section 1, a new #1 contender. It's time to dig into the data behind that huge claim.
So check this out. This chart is from Artificial Analysis, and it's showing a composite intelligence score. This thing tests pretty much everything, from math to coding, and wow, look at these results. MiniMax M2 is right there in the thick of it with the biggest names in the game. We're talking shoulder to shoulder with giants like Gemini and Claude. So yeah, this isn't just hype. This thing is a serious contender. Okay, so that begs the question, right? How in the world does an open source model pull off this kind of performance? Well, that leads us straight into Section 2. Meet MiniMax M2. The name itself is a pretty big clue. Mini size, max performance. And it all comes down to its really clever design. So the secret sauce here is something called a mixture of experts architecture, or MO for short. Now what is that? Well, think of it like having a big team of specialists. Instead of forcing the entire team to solve every single problem, an MOE model is smart. It routes your question to only the handful of experts who are perfect for that specific job. And that is the key to its incredible efficiency.
And this visualizes it perfectly. Imagine the model's total 230 billion parameters is a gigantic library. I mean, an absolutely massive one. Now, a normal model might try to read every single book in that library all at once for your question, which is insane, right? But MiniMax M2 is way smarter. For any given task, it only activates about 10 billion parameters. It's like walking into that huge library and knowing exactly which handful of books you need to pull off the shelf. That's what makes it so incredibly fast and lean.
So because of this super focused design, it excels at 4 key things. It's got superior general intelligence. It's a pro at advanced coding and fixing tests. It performs really well on complex agent tasks. And this is the kicker. It does all of this with a super efficient, cost-effective design.
Okay, so that's all the theory. But how does it actually perform in the wild? That brings us to Section 3, Performance Under Pressure. Let's put these claims to the test with some real-world benchmarks that developers really care about.
So, first up, a question that every coder wants to know. How does this thing actually handle tasks in a command line? You know, the terminal, the bread and butter of a developer's workflow. And the results on this benchmark, Terminal Bench, are pretty revealing. Look at this. MiniMax M2 is holding its own against Claude, and it even edges out a thinking version of GPT-5. This isn't just a random number on a chart. This means the model is genuinely good in a core hands-on developer environment. That's a big deal.
Okay, so it can handle a terminal, that's great, but what about something more complex? Something with multiple steps? Like, can it act as an agent and go out and browse the web to get stuff done for you?
So on the Browse Comp benchmark, it pulls a really solid 44. Now, yeah, one model is a bit ahead, but look where MiniMax M2 is. It's right there in the mix with the other top dogs. This confirms it's got some serious skills when it comes to those agent-style web browsing tasks.
All right, now for what I think is the ultimate test for any coding model. Can it dive into a huge, messy, real-world code base and actually fix bugs? That is exactly what the notoriously difficult SWE benchmark is all about.
And look at this. On what is arguably one of the toughest coding tests out there, it scores a 69.4. Now, okay, it's a bit behind the top proprietary models from Anthropic and OpenAI for sure, but posting a score this high, that proves it has some serious engineering skills for complex, real-world coding.
So we've seen that it performs. The numbers are there. But why? Why is it so good at these interactive agent-like jobs? Well, that's what we're going to cover in Section 4, the efficiency advantage. This really is the secret behind its speed.
See, when an AI acts like an agent, it's constantly in this loop. Plan, act, verify. Over and over. So for a coder, it's like plan a fix, act by writing the code, and then verify by running a test. And the speed of that loop, that's everything. A slow loop is a useless agent. And this is where only using 10 billion active parameters becomes a total superpower. It means those feedback cycles are way faster. The model can think, act, and check the results in a flash. For you as a developer, that means you can run way more concurrent tasks on the same budget. And planning out your server needs, it becomes so much simpler.
You know, the creators really summed it up perfectly. 10 billion activations equals responsive agent loops plus better unit economics. Let me translate that. The AI is faster, and it's cheaper to run. That's pretty much the holy grail for anyone building with AI agents.
Which of course brings us to our final section, your turn to try. Because after seeing all of this, I bet you're wondering, okay, how do I get my hands on this thing?
Well, you've got 3 awesome options. You can jump right in and use their public MiniMax agent product. If you're a developer, you can hit their open platform API. And this is huge. For anyone who wants to tinker with it locally, the model weights are totally open source on Hugging Face. And the best part? For a limited time, it's free to get started.
Okay, listen up, because this is super important. If you're going to use this model, there's one thing you absolutely have to know. The model uses these special think tags to show its work, to lay out its reasoning. You must keep those tags in the conversation history. Seriously, if you strip them out, performance is going to fall off a cliff, so don't do it.
So what's the bottom line here? What's the big takeaway? It really seems like MiniMax M2 has found that perfect sweet spot. You're getting the kind of powerful, agent-like coding skills you'd expect from one of those giant, super expensive frontier models, but you're getting it in a package that's efficient, cheap to run, and open source.
And that really leaves us with a huge question about the future of AI, doesn't it? Is the future going to be owned by a few giants building bigger and bigger, more expensive models? Or is the future going to belong to these smaller, faster, more efficient models like MiniMax M2? It's definitely something to think about.